Okay, so let's have a go at exercise 2.1. So we want to show if beta has a derivation from alpha and gamma has a derivation from beta, then gamma has a derivation from alpha. And the hint tells us to try induction on the number of steps in the second derivation. So that's what we're going to do. Okay, so we'll begin the proof. So what's our base case going to be? Our base case is going to be derivations of length 0. Okay, and what's the derivation of length 0? Well, derivation of length 0 we just do nothing, right? It's the do nothing derivation, which is you leave the string the way it is, right? So, trivially, if I take beta and I do a derivation of length 0, the only possible derivation that can be is leave beta the way it is. So that means gamma must be equal to beta. And if we want to show gamma has a derivation from alpha, well, we know beta has a derivation from alpha, and gamma and beta are the same thing. So that means we sort of immediately get that gamma has a derivation from alpha. Okay, so base case was easy, as it usually tends to be. So step case. So we will assume that it's true for all strings gamma derived from beta with n derivations, and then we'll prove the statement for all strings gamma prime that are derived from beta of length n plus 1. Okay, so if gamma prime has a derivation from beta of length n plus 1, well, what does that mean? It means that there is some string alpha such that alpha can be deduced from beta in n steps, and gamma prime can be deduced from alpha in exactly one derivation step. Now, by our induction hypothesis, we assumed that this property here was true for all derivations beta to alpha of length n. So, I'm sorry, I shouldn't have used alpha again, because I used alpha over here. I used a different Greek letter, rho. There we go. Some rho in the middle. There we are. So, if alpha goes to beta and beta goes to rho, and this derivation is of length n, then that means I can conclude alpha goes to rho by my induction hypothesis. And if alpha goes to rho in so many steps, and in one more step rho goes to gamma prime, then that means alpha under some number of derivation steps gets to gamma prime, because we just add this extra step on the end, right? And that gives us the statement that we wanted.